So in this video, we will discuss about the introduction to design and analysis of algorithm subject. So this is design and analysis of algorithm subject, what the students will learn. And before this DAA, you should learn the data structures concept. So if you take any university syllabus, whether it is NIT, IITs, foreign universities, or Indian private universities, or government universities, so definitely this DAA subject will comes after the data structures. So if you learn data structure in the third semester, then you will learn DAA in the fourth semester. So why that algorithms can be written using the data structures only. So before designing and analyzing the algorithm, you should know the data structures by which the algorithms can be designed. So what is an algorithm? So algorithm is a solution to a computational problem. So that is called algorithm. And how to write an algorithm? So for writing algorithm, first step, you should identify a proper data structure. So which data structure can be used to solve this particular problem or designing the particular algorithm. So for any computational problem, we cannot say that a problem has a single solution or unique solution. Any problem can be solved in a different way. So each one may come up with a different logic for solving that problem. So for example, if you design a algorithm, if you write an algorithm for sorting a number of elements, so you can come up with a different algorithms. So already existing algorithms also, many different kinds of algorithms are available, like insertion sort, bubble sort, quick sort, merge sort, then selection sort. These are the different algorithms that are available or already designed for sorting problem. So in this DAA subject, first you will learn how to design a efficient algorithm. For designing, we can use different approaches. These are called designing approaches or designing methods. So some of the designing methods you will learn are brute force approach, divide and conquer approach, greedy approach, dynamic programming, and then randomized algorithms. So for sorting, insertion and bubble sort. So these algorithms are designed using brute force approach. So and then quick sort and merge sort. These are the algorithms or solutions that are designed by using divide and conquer approach. And selection sort is a greedy approach algorithm. So this is actually designing part. So these are the various methods. So each method follows its own methodology to design a algorithm. So in a brute force approach, we are not going to use any kind of special logic. So we will solve the problem as it is. So there is no any other methodology. So in divide and conquer approach, so this approach follows, first we will divide that entire problem into a subproblems. So and then we will solve each subproblems independently. So and then once you find the solution for each subproblem, and finally we will conquer, or we will merge all these that sub-solutions into a single solution. So that is divide and conquer approach. So in the same way, greedy approach has its own methodology and dynamic programming has its own methodology. So you will study how to use these methodologies to design a algorithm. And next part, that is analysis part. So in this analysis part, you are going to analyze the performance of the algorithm that is designed. So why we need to analyze it? As I already told you, for a given problem, we can come up with multiple solutions. So for example, so if you want to travel from Chennai to Mumbai, so this problem have multiple solutions. You can travel by flight, you can travel by bus, or you can travel by train. So in order to pick which one is best, for that you should have some criteria. For example, in this problem, the criteria are time and money. So if your criteria is time, that means you need to reach Mumbai with minimum time, so minimum duration. Means you will select flight. So by using the flight only, you can reach within 4 to 5 hours. Suppose if your criteria is money, so time is not a constraint, so you need to reach Mumbai with minimum money spent, then you will select train as a solution. So in the same way, for a given computational problem also, you may come up with multiple solutions. For example, for sorting, one person come up with a solution A, and another person comes with a solution B. So now we need to select which solution is best, which one is a efficient solution. So for that, we should have some criteria to analyze, criteria to measure the effectiveness of that algorithm. So here, the criteria is computational time it takes to solve the problem. How much computational time it takes. So computational time is nothing but how many instructions it will execute to solve that problem. So if an algorithm can solve your problem with minimum instructions, minimum instruction means CPU instruction, with executing a minimum number of CPU instructions, then it is the best algorithm. Suppose plan A takes 100 instructions to complete, plan B takes only 50 instructions to complete the same solution, then plan B is the best. So this criteria here, it is called time complexity of a algorithm. So in the analysis part, you will study about how to measure the time complexity of an algorithm. So I will explain this importance of this analysis part with one simple example, the same sorting problem. So let us take a problem of searching an element in a sorted array. You are given with a sorted array. So we need to search an element, whether that element is present in that array or not. So this is a dictionary search problem. So here the same problem can be solved in two different methods. First one is by using a brute force approach, and second one is by using a divide and conquer approach. So the brute force approach, that algorithm is called linear search. Okay. So first I will explain. So what is the solution and how much computational time, how much instructions it needs to complete it. So in that linear search, suppose the given array is this is the given array. So from this array, the element that is the key to be found is, for example, 14. That means the key is not in that list. And now I am going to write a computational solution for this. So here we are going to use a linear search method. So in the actual logic is starting from the first element, I will compare the element with the key. So if the element matches with the key, then I will return a true. That means the element is found. So if it is not matched, then I will move to the next element and I compare the next element with the key. So this process should be repeated until we reach the end of the array, or the any element in that array matches with the key. So here, first we need to match. So we need to compare the first element 2 and 14. So 2 is not equal to 14. Okay, so this match doesn't give true. So next I need to go to the next element, that is 6, and I will compare 6 with 14, and 6 does not equal to 14. So this is also not. Then I will move to the third element, so 8. So 8 is not equal to 14. So this match is not found. Then I will go to 10. So 10 is not equal to 14. So here also it doesn't match. So and then 12. So 12 is also not match with 14. So after that, no element found. No element in the list. 12 is the last element. So now we reach the end of the list, end of the array, and none of the element matches with the key. So we may return false, the element not found. So in this particular algorithm, so how many comparison we done? So we did 5 comparisons. So the number of comparisons that need to be done for completing the solution. So here the result is the element not found. That is the solution. So for generating the result, the correct result. So in this particular logic, I need to do 5 number of comparisons. Suppose if I take this each comparison as a single CPU instruction, then this algorithm takes 5 computational units to complete the solution. Now I will move to the next method. So that is method 2. So method 2, here I am going to use a divide and conquer approach. So divide and conquer approach. So in the divide and conquer approach, I am going to divide that entire problem into subproblems, and then I am going to solve a subproblem to find the solution. So now for the same input 2, 6, 8, 10, 12. So this is the input. So 2, 6, 8, 10, 12. So and then the key to be found is 14. So in this solution, first I am going to compare this key with the middle element in the list. So how to find the middle element means, so the middle element can be calculated by the number of elements plus 1 by 2. So here number of element is 5. So 5 plus 1 by 2 equal to 3. So first I will compare this key with the middle element. So here the middle element is 8. So and then 8 is not equal to 14. So if the middle element is equal to the element to be searched, then we can return true. Suppose if the middle element is not matched with the key to be searched, then I will compare the value of this middle element with the key. So here the middle element is less than 14. So after this comparison, I can able to find if the key is present. If the key is present in the list, then it should be at the right side of the element 8, because that array itself is a sorted array. So if the key is greater than 8 means this key definitely will not be in the left side of 8, because the left side of 8 part only contains the elements which are less than 8. So now I can completely ignore that left part. So now I can reduce my search with only the right part of my problem. So now I need to search that key only with the right sub part of the key. So now I divide my entire problem into half. So now I repeat the same thing. So here I need to find the middle element. So the middle element is the number of elements 2 plus 1 by 2 equal to, this is 1.5. So 1.5 we can take a floor value, that is 1. So we can take first element as a middle element. And I compare 10 with 14. So now 10 is not equal to 14. Again I will compare. So 10 is less than 14. So if 14 is found, then it will be at the right side of the 10. So now I am only take the right side of middle element 10. So it contains only one element. So now I compare that element with 14. So 12 is not equal to 14. And this is the last element, only one element. So we need not to further divide my problem. So we reach the end of the input. So now I can able to return the element not found. So in this case, how many comparisons I have done? So only 3 comparisons. So first I compare 8 with 14. So and then I divide that array into a subarray, and then I compare 10 with 14 and I compare 12 with 14. So now I did only 3 comparisons. So that means with 3 computational CPU instructions, I found the result. So in the first approach, I use a brute force approach that is called linear search. So that linear search, for this simple example only with 5 elements, it takes 5 number of comparisons. So in general, if the input size is n, then it takes n number of comparisons. That means n number of CPU instructions should be executed. But here, the same problem I solve with a divide and conquer approach. So in this approach, the same problem can be solved only with 3. So if the input size is 5, we can solve it only with 3. So actually, if the input size is n, then with log n comparisons, we can able to find the solution. So we have 2 approaches. In brute force approach, it takes n number of comparisons, or the time taken is n units. But in the computation, in the divide and conquer approach, the same problem I can able to solve with the time log n. So which one is best? So this log n is the best one. So as a summary, so in the design analysis of algorithms, you will study about how to design an efficient algorithm and how to analyze the efficiency of the algorithm in terms of time. So why this DAA has more value in terms of placement? So I will explain this with an example. Suppose if you are using a mobile phone, Android phone, and you are installing some browsers. So if suppose on browser, it takes a lot of time to load the website. So in the left side, I saw one browser. That browser, the time to load is very long. So why the browser is designed in that inefficient way? It takes O of n squared time. The actual software, the algorithm that is used for designing that software takes O of n squared time to respond, to give the result to the user. So in the right side, I'm using another browser. So that browser retrieve that result, retrieve that websites fast, in a fast way compared to the slow browser. So the reason here is the same software, that fast browser, it is designed using a efficient algorithm. So that algorithm which takes less time to produce the result. So if you are using these two browsers, so which one we will prefer? Definitely you will prefer go for the browser, that fast browser in the right side. So, as a software engineer, so if you are developing any software, so you should work with a lot of algorithms, and you should design that algorithms in a more efficient way with respect to time complexity. So, apart from designing an algorithm, you should also know how to analyze it. So that's why that DAA concept have much value in terms of placement. So if you like this video, subscribe to my channel. So I will post a lot of videos related to this DAA design analysis of algorithms topics in future. Thank you.